All right, awesome. Let's go ahead and get started then. So my name is Ashwin Kumar, and I'm a product manager at Tableau on the Maps team. I've been on the team for a little bit over 2 years now, been a Tableau user for 4 years, and this is my 4th Tableau conference. Quick question for all you in the room. Who's here for your very first TC? Awesome, all right. Anyone here for your second or more TC? Cool, very cool. So I'm really glad that you guys are all here with us this week. This is really, in my opinion, one of probably the best TCs yet, so it's great that you're all here to share experience with us. Now, if your raising of hands was any indication, we have a good mix of skill levels or experiences with Tableau in the room, and that's great. Because even though today's session is called a beginner's guide to maps, it's really meant for all skill levels. If you're a brand new Tableau user or a brand new maps user, you'll find this session very useful to learn the basics of maps in Tableau. And if you're a bit more experienced with the product, today will be a good refresher on how maps work in the product. Let's go ahead and get started, though. Actually, before we get to the product, I want to talk a little bit about how we on the Maps team approach Tableau and mapping. So traditionally, when it comes to BI, or business intelligence, and GIS, or geographic informational systems, these things are pretty separated in companies. Right? If you, as an analyst, have a question, you might go to your GIS team to learn about the where and analyze mapping data. You might go to your BI team for everything else. But at Tableau, we said, that doesn't make a lot of sense. Right? Because all of us have questions that have to do with the word where, or questions about location data. So maps in Tableau are meant to be really easy to use so that everyone, even if you don't have that deeply technical mapping background, can answer questions with location data that have to do with the word where. So let's dive in. So this is Tableau Desktop, and this is what you see when you first open up the product. Now, of course, when it comes to analyzing and visualizing data, the most important thing to have is, well, your data, right? And Tableau can connect to many different kinds of data. Now, when it comes to mapping data, it's really no different. For example, looking in the top left corner of the screen, we can connect to Microsoft Excel spreadsheets that have latitude, longitude data, maybe points on a globe, or CSVs that might also have latitude, longitudes. We can also connect to native spatial files, things like Esri shapefiles, Esri file databases, TopoJSON, GeoJSON, and more. Now, if your data lives in the cloud in a mapping database like Microsoft SQL Server Spatial, Postgres, or PostGIS, we can connect to that as well. The name of the game here is that Tableau wants to connect to your location data wherever and however it lives. But to kick it off, we'll go ahead and open up a standard Microsoft Excel spreadsheet. We'll just click on that, and in the Finder, we will find the superstore.xlsx worksheet. Now, Superstore is a great place to start because actually all of you have access to the exact same data set. This data set ships with every single version of Tableau. And in this case, we should all put on our analyst hats for just 1 second. So imagine that we are all analysts at a nationwide department store, and we sell products across the lower 48 United States. And we have questions about our business, things like, where do we sell more and less? Or where are we more profitable or less profitable? Let's answer those questions. So in the top left-hand corner of the screen, we'll drag the orders sheet onto the view. And the bottom half populates with a preview of your data. Now, this is really useful to see because you can immediately look through your data set right here in Tableau to understand what kinds of questions you can ask and answer. So here we can see we have some order information like the order ID and the order date, the shipping date, the shipping mode, some customer information right there, some location fields like country, city, state, and postal code of the order, as well as some product information over here. For example, like what category did the person make the purchase in, and what subcategory. And then finally, on the far right-hand side of the screen, some quantitative information about sales, quantity, any discounts that were applied, and overall profit for that particular order. So once we're all familiar with the data set, we can pop into the analyst view in Tableau. We'll do that by clicking the bottom left-hand corner where it says Intro to Tableau. So this is Tableau, the blank canvas. Now, looking on the far left side of the screen, you can see an area called Dimensions, and below that, an area called Measures. Now, everything in the Dimensions and Measures areas were what we saw in the previous screen, right? All those data column headers are in this left side panel. Now, dimensions are things that are categorical in nature, and measures are things that you can count. Now, one more thing I want to point out is you'll notice a small icon next to each header in the data pane. For example, category has an ABC icon, country has or city has a globe icon, and order date has a calendar icon. This tells you what is the type of data stored in that particular column. So for example, category is a string, city is a location field, and order date is a date, time, or calendar field. Now, of course, this is a mapping talk, so we'll drill a bit more into those location fields. So clicking on that globe icon next to city, we can go to the geographic roles menu. And we can see that not only has Tableau categorized city as a location field, but it also knows that city is a city. And it's done the same thing for country, state, and postal code. And actually, it can do this kind of automatic role detection for any of the 10 roles you see on the screen here in 11 different product languages. Now, why is that important? Well, it's important when it comes to a concept called geocoding, which we'll get to in just a few minutes. Now, making a map in Tableau is meant to be really easy. We can just take any one of our location fields. So for example, we can take country and drag it onto the view, just like that. And boom, Tableau knows how to make a map. It's just that simple. Now, when it comes to location data, we have a very interesting concept called a hierarchy, right? For example, countries are at the top, made up of states, which contain cities, which contain postal codes. And one common thing that users want to do is to be able to drill up and down on that hierarchy. Let's make that in Tableau. To do that, I'll hold down the Command button on Mac or Control on PC, and I'll select every different data field I want related in my hierarchy. For example, I want city, country, postal code, and state to all be in the same hierarchy. I'll go ahead and right-click on state, go to hierarchy, create hierarchy, and click that. Here we can give it a name. In this case, we'll just call it hierarchy, and hit OK. So now in the top left-hand corner of the screen, you can see we have our newly created hierarchy with our 4 data fields inside. However, the ordering of those fields is incorrect. Right? As we just said, we want country at the top, then state, then city, then postal code. So let's fix that. We can take country and just drag it right above city. We can do the same thing with state. All right, that looks a lot better. Now, those of you with sharp eyes may have noticed that right here in the marks card, when we made that hierarchy, a small plus button appeared. Clicking on that allows us to drill down from country to state directly in the map. Now, something actually very subtle yet powerful happened there. Did you guys catch that? Let's do it again. Let's hit that minus button, go back to country, hit that plus, and go down to state. So my question for you is, how did Tableau know where to put that mark for the United States? And in this view here, how does it know where to draw each data mark for each state? Because if you recall, in our data set, we didn't actually have any information about latitudes and longitudes or anything like that. And actually, if I were to make this a filled map by going here to the marks card, clicking the drop-down, and clicking the map option, we can actually make a filled map that shows a polygon for each state. Now, how did Tableau know how to do that? Because we didn't have any of that information in our data set. Well, that's because of our in-product geocoding. Think of it like this. Essentially, on the back end of Tableau, we have this massive data table that maps countries and states and anything else in those 10 geographic roles to points on the globe and polygons where applicable. So for example, California is a state, it has an area, so we have that polygon here. Whereas Las Vegas is more commonly known as a point or a city, so there's no area for Las Vegas. So what's happening here is when we put state onto the view, Tableau looks up all the different states in our data set in that database and puts the right thing on the map. Now this is so powerful for a few reasons. Number one, it allows us as users to not have to provide any special information to see a map. All we do is provide the name of the place we want to see, and boom, Tableau does the rest. Now the second most powerful thing here is all this geocoding happens right here on my laptop, in my secure environment. No information is being sent on the internet or anywhere outside of my environment. So this is all right here, safe and sound. Let's make this into a point map again. Oh, sorry. There we go. All right. So now we have our map in Tableau. Let's get some data on there. Going down to the bottom left-hand corner of the screen to the measures area, we'll take profit and put that onto label. Boom. Just like that, we got a map, data on it. We're all done, right? Who here thinks this is a great map? Anyone? Man, you guys are mean. I agree. It's not a great map. It's not even a good map. In fact, it's probably quite a bad map, right? For example, if I asked you, what is the least profitable state in the US? What is it? Go. Just shout out when you got it. What is the least profitable state in the US? I heard Pennsylvania, Texas. We don't know, right? It is Texas. Whoever got Texas, you got it right. But the point is, that was really hard, way harder than it had to be. Because what we're doing here is looking at each individual label and comparing it to every other label and figuring out what is the smallest number that we saw. But that's not how data visualization should be. It should be way easier. So let's take that profit measure from the marks card here in the green, and instead we'll put that onto color. So Tableau did two things here automatically. First, it picked out its own color scheme. In the top right-hand corner of the screen, you can see a small color legend that shows us that the places in orange are less profitable, places in blue are more profitable. It's also made the map into a filled map automatically, because it thinks that this is what we want to see. And I agree with it. I think a filled map is a great choice for this type of view. And now here we can clearly see that Texas is the brightest orange. It is the least profitable state in the United States. And California and New York are dark blue, the most profitable states. Now, those of you with especially sharp eyes may have noticed in the bottom right-hand corner of the screen, there's a small unknown indicator that says 1 unknown. What's going on there? Well, it turns out, right, we do business in all 48 contiguous United States, as I mentioned earlier, but we're actually missing a state. If we go up here to the northeast, we can see that there's actually no data for Delaware. And that's what that unknown indicator in the bottom right-hand corner is telling us. It's saying that there's a problem in the data. So let's fix that. We'll click Unknown in the bottom right-hand corner and click on Edit Locations in the resulting dialog to see what's going on. So in this case, it looks like we have a place called Delaware in our data set, whereas Delaware is spelled actually with an A after that L. Now, ordinarily, we might have to go back to our data source if we even have access to fix that data to make it appear on the map, or you might have to go to your data steward in your organization and say, hey, there's an issue, please fix Delaware, come back next week and then build your map, right? That's kind of annoying. So luckily in Tableau, we can fix that right now. We can just click Unrecognized and type in the correct spelling of the place we want to see. So in this case, we'll type in Delaware and click OK. And just like that, a mark has appeared for Delaware showing almost $10,000 in profit. Now the cool thing here is that this fix that we just made happens directly on my machine. So it's not actually writing back to the data source, so I'm not actually making an edit to that underlying source of truth. So what I can do now is tell my data steward that, hey, there's an issue, please fix it. But we're not blocked in our exploration of this data set. Oops. Now, there's more we can do here. Right now we're looking at a map that shows a choropleth, or a shaded map of profit across the United States. But what about other types of measures? For example, what if we wanted to see the quantity of goods sold across each state? Because maybe that's the reason why Texas is so unprofitable. Let's find out. We can simply take quantity from the bottom left-hand corner of the screen and put that onto size in the marks card. And we'll make those marks a bit bigger so it's all easier to see. So now what we're looking at here is the bigger the circle, the more quantity of goods sold in that state. And again, the color scheme is the same. Orange is less profitable, blue is more profitable. So in this view here, we can see that California and New York are more profitable, and we sell a lot of goods there. So maybe we'll double down in those states. Whereas Texas is highly unprofitable, and we sell a lot of goods there, so clearly something else is going on. Now, we could go further and try and figure out what's going on there, but we're actually going to move on to the next example. However, for the first 3 folks to figure out what's going on with Texas, email me afterwards, I'll give you a Starbucks gift card. All right. So moving on to the next example. I want to show you one that has a bit more data. So I spent a lot of time browsing memes on the internet, probably more than I should. And I saw this Facebook page go viral this summer. It's called Storm Area 51, They Can't Stop All of Us. Was anyone here in attendance at this event? I mean, it's okay if you were, right? I mean, I'm not going to judge. But actually what's crazy is that over 1,500 people actually went to this event out in the desert. It's insane. Now, I wasn't there, but this definitely got me thinking about, UFOs in the United States. So I wanted to understand what is the history of UFO sightings in the United States. So I went online, found a data set, and analyzed it in Tableau. Let's take a look. So here we'll go to the bottom left corner of the screen, click the UFO map worksheet, which is empty currently, and we'll connect that UFO sightings data set. To do that, we'll go to the top left corner to the Tableau icon and click on that. That takes us back to the Connect to Data page. Now, I happen to know that the UFO sightings data set is actually, again, an Excel spreadsheet. So we'll click Excel, and we'll click on UFO sightings. Now, again, just like before, we have the data preview here. So we can see that we have a summary of what happened in the sighting. We have the country, state, and city of the sighting. We've got the date and time that the sighting took place, the shape that was seen in the sky, and finally the duration in seconds of the event. So I want to understand just how UFO sightings vary across the United States. Let's take a look. So going back to this UFO sightings map worksheet, we'll again make a map. And just like before, it's very simple. We'll just take a country from the top left corner of the screen and drag it on the view. And boom, Tableau makes a map, and we can see that in this data set, we have sightings in two countries, Canada at the top and US at the bottom. Now, I want to focus more on the United States, so I'll actually go ahead and exclude Canada from the data set. To do that, we'll select that mark at the top of the screen and hit exclude. And we got rid of Canada for the time being. Now, drilling down from country to state by clicking that plus button in the marks card, we can see that we actually have UFO sightings in all 50 US states. Now, again, in this case, I want to focus just on that contiguous US, so I'll go ahead and exclude Alaska and Hawaii. I'll just select each mark and click exclude. Now, you'll notice as I do this that the map is automatically refocusing. So what Tableau is trying to do is be smart with your data. It's trying to keep your data that you care most about front and center in the view. And of course, I can turn that capability on and off by clicking the small pin icon right here in that toolbar. But for now, I'll just leave it on. So here we have a map that shows all the different contiguous states in our data set. Now, drilling down one more time in the marks card from state to city, we can see all the cities in the data set where UFO sightings have occurred. Now, if you look at the bottom right-hand corner of the screen, you'll see another unknown indicator. Let's click on that and see what's happening here. So again, it pops that familiar dialog, and we'll click Edit Locations. And we can see that there are a bunch of cities and towns that are just unrecognized by Tableau. So what's going on? Well, it turns out that that geocoding database has a finite size. And unfortunately, it doesn't have every single city and town in the entire world. So in this case, what we're looking at is most likely very small cities and towns. In the United States, Tableau has a limitation at about 1,000 people or so. We stop supporting cities and towns. So in this case, these are all probably just very small cities and towns. So to get around that, I might bring in my own latitude, longitude coordinates and type them in. But in this case, I won't do that. We'll just keep moving on. So this data right here is very dense, right? We have a lot of points, and it's unclear exactly what's going on. There's no clear pattern here, right? Luckily in Tableau, there is a built-in mark type, just like size and color, that can help us understand dense data. And it's called the density mark type, or heat map. We can use the heat map by going to the marks card right here, clicking the drop-down, and clicking the density mark at the bottom of that menu. So just like that, Tableau has made a heat map showing us where there's a higher concentration of UFO sightings. So here, clearly, there's a higher density of sightings in the Southern California area as well as in the Northeast. Now, in my opinion, this color scheme is okay, right? This blue is all right, but I want something different, right? For me, the color green kind of reminds me of aliens. So let's change this color to make it green. In the mark chart, we'll click on the color option right there and hit this drop down. And we can see that we have so many different color schemes available for use. Now I'm going to use that density green dark color palette. All right, that looks a little bit better. We'll make that intensity a little bit higher so that those dense areas in the southwest and northeast really pop. So this is cool. I think this looks pretty good. But there's more to it, right? So far, all we talked about is the foreground of the map, your data that lives on top of the map. And we have not talked about an equally important part of the map, which is the background. The background is so important for two primary reasons. Number one, it allows you to share context with your viewers or consumers of your viz. Now in this case, we're probably all familiar with the United States as a whole, so this context is probably good enough. But imagine if we were zoomed in on a random suburb in California, or a random countryside in Germany, or a random coastline in Japan. We might want to see better context to understand what's happening in that background map. But the second reason why a background map is very useful is for aesthetics. It just makes the map look better. So in this case, given that we're all familiar with the United States, we'll actually go ahead and change the aesthetics of the map to make this thing look a little bit better. To do that in Tableau, we'll go to the top of the screen where it says Map, and click Map, Map Layers. Now looking at the far left-hand side, you can see the Map Layers pane has appeared. And there are a bunch of different options here that we can use to customize our map. Starting at the top, there's a background style that we can choose from. Right now it's using the light style, but clicking that drop-down, we can see that we actually have 6 built-in styles in Tableau for use out of the box. Light, normal, and dark, streets, outdoors, and satellite. Light, normal, and dark, the first 3 are best used for those general use cases, not anything specific. And satellite, streets, and outdoors are best for very specific use cases. But right now, let's have a look at those first 3. So clicking on normal, we can see that background map view changes instantly. And okay, the water is a bit bluer, I guess, and the background color is a little bit grayer, but it doesn't quite look as good as I want it to look. How about the dark style? All right, now to me that looks pretty cool, so we'll stick with this. And we'll explore those last 3 styles in a different example. So besides those background map styles, we can also adjust other facets of the map, like the washout, for example. So if you keep your eyes on this portion of the map as I change the washout, we can see that the background map view starts to fade just a little bit. And I can go all the way to 100%, and the background map view will disappear entirely. Now besides the washout, which I'll put back to 0, we can also adjust a setting called repeat background. Let me show you what that does. So if I were to zoom all the way out on the map, I can see that the map has kind of those edges, right, where it just kind of stops. Clicking repeat background causes the map to repeat. I'll turn it off for now. Now, aside from washout, styles, and repeat background, we can also toggle all of those background map layers to really customize that background map context. For example, if you keep your eyes right here on the state of Wyoming, I can turn off the state labels. I can also turn off state borders, country names, as well as country borders. Every single thing in the background map can be fully toggled on and off so you can have the perfect context for your viewers. In this case, I'll turn those things back on. Then finally, going to the bottom of that map layers pane, we can see an area called data layer. Clicking on that dropdown shows us 20 different demographic data indicators sourced directly from the ACS census. Clicking any one of these options, for example, household size average, shows us a color-coordinated map in the background of the average household size in each state. And I can actually go ahead and change that granularity to be county, zip code, or census tract. I can even choose from any one of these color schemes built into the product. Now, in this case, these indicators are probably not that useful for us when it comes to UFOs, so I'll go ahead and turn those things off as well. Now, if you wanted to go a bit further with the analysis of this data, you might end up with a dashboard that looks something like this. Now, this view is so cool because what's actually happening here is the bar chart is connected to every other aspect of the dashboard. So if I were to click on, I don't know, 2012, the label shows that we had over 7,000 sightings of UFOs in that year, and the heat map shows where those sightings occurred in that year. So if I were to click on 1995, I can see that we had 1,300 sightings in the US, and they were clustered up there in the Pacific Northwest. I wonder what happened there. I have no idea, but now we can go and look at that data as well. So far we've connected to two Excel spreadsheets, right? The superstore and UFO sightings. But what about other kinds of data? What about spatial files? Let's have a look at that for a sec. So going here to the top left corner of the screen, we'll click on the Tableau icon and click on Spatial File and search for this shapefile right here, which is SF Police Districts. So my story here is before moving to Seattle to work at Tableau, I was actually from San Francisco. And unfortunately, I noticed over the past few years, crime has increased in the city of SF. And I wanted to understand across which police districts is more and less crime happening. Let's have a look. So we'll click on the shapefile here that contains information about police districts in SF and hit open. Now the amazing thing here is that none of us had to know exactly what a shapefile is. Now I can tell you that a shapefile is a kind of spatial file format that contains custom geographic information. So for example here, Tableau couldn't possibly have all of the police boundaries across the entire country, across the entire world. So I'm bringing in my own custom shapefile that has boundary information about each police district. But the thing is, that's all we have to know about it. We don't have to know how it works, how to make it, anything like that. Just connect it in Tableau and go to our worksheet here. And again, just like before, we can take the location field, which is geometry, as shown by that small globe icon to the left, and drag that onto the view. And Tableau knows exactly what to do. So here I brought in my own custom police districts into Tableau that shows me where the boundaries are. Now, if I hover over any of these districts, you notice that I'm actually hovering over all of them, right? I've selected all of them. That's because Tableau wants to automatically aggregate all of our measures. So let's disaggregate those measures. We'll take any unique identifier. So in this case, in the top left corner, we'll look at the district name and drag that onto detail in the marks card. So that's going to disaggregate all the different marks in our view. So now I can hover over each police district independently and see Taraval, the Mission District, and the Northern District. Okay, that's cool. We now have our custom boundaries in Tableau. But what about the crimes, right? Because our question that we wanted to ask in the beginning was, which districts have more and less crime? To do that, let's load in a brand new data set. So I'll go to my individual crimes worksheet here, and again, go to that top left corner of the screen, and hit that Tableau icon. Now in this case, my crimes data set is again another Excel spreadsheet. So we'll hit Excel and load that in. Here it's called, let's see, sfcrimes.xlsx, and hit open. So again, just like before, we have this data preview window that shows us all the different data fields in our data set. We have things like the incident date, so when the crime occurred, and the time as well, the year of the crime, the day of the week that the crime occurred, the incident ID and incident number. Going to the right, we have categorical information about what kind of crime it was, whether it was an assault, a robbery, a larceny, theft, or something else. And finally, on the far right, we have the police district in which the crime occurred, as well as the latitude and longitude. Now keep in mind that this police district that you see here is just the name of the district. It has no other information about that district. So going back to that individual crimes worksheet, we can load in all those crimes into Tableau. Again, by going to the bottom left corner of the screen and selecting those geographic fields. In this case, we have latitude and longitude. So I'll hold Command on my Mac or Control on your PC and select latitude and longitude, zoom out, and I'll just drag those onto the view. Oop, I only dragged one. Let's get them both. I don't know why it's not working. Let's just do this. All right. So now we have our map that shows crimes in SF. Oh, wow, look at that. Only one crime. I guess it's a pretty safe city after all, right? Now, so what's happening here is actually, again, Tableau is aggregating all of that data and showing us the average latitude, longitude of all the crimes in SF. So we need to break that data apart and disaggregate that, again, with that unique identifier. So here, I believe the identifier is incident number. So we'll take that from the left-hand side of the screen and put that again onto detail. So now we have one mark drawn for every single crime in San Francisco. This is almost 40,000 crimes that occurred year to date this year. And hovering over each mark, we can see some information about the incident number, the latitude, longitude, and if I were to drag the incident category onto detail as well, I can hover over each mark and I can see the category of the crime that occurred. Now, one thing that I haven't mentioned is, of course, that background map, right? What is happening there? This is insane. So in Tableau, right, we have those three brand new background map styles, the satellite, streets, and outdoors. And obviously here, this one is a satellite imagery view. And this is amazing because I can go anywhere in the world, for example, the Bahamas, and I can see just how detailed this imagery really is. I can zoom all the way in on those beaches and see that bright blue water and those white sandy beaches, and I know where I'm going to go at the end of this talk. Now, going back to San Francisco, we can explore the other background map styles. For example, so going back to that map layers pane at the top of the screen, we can select the street style. And I'll make those point marks a little bit smaller so we can actually see that background map. I'll just click on size in the marks card and bring that down. So what we see here with the street style is a highly detailed Google Maps type of view directly in Tableau. Of course, we can see that parks are colored green and medical centers are colored pink, and education centers like the University of California here are colored gold. And zooming all the way in, we can see so much more detail in the background view. For example, we can see here things like train stations, like the 16th Street Mission Station down here. Or we can see a label for the hospital there. Of course, there's the street labels as well as the highway coloring and road shields too. Now, zooming all the way in, I can even see building footprints and more points of interest appear. So I have those shadings that show where each building is located, and I have information about where Carlin's Cafe, Skunk Funk, and Box Dog are located as well. And of course, like before, all these elements are fully customizable and toggleable on and off. So I can go ahead and turn off those building footprints or turn off those points of interest to really customize what's happening in that background map view. But here I'll go ahead and just turn those things back on. And then finally, looking at the outdoor style, this one looks very similar to streets when it comes to an urban setting, but going to a place that's more nature-y. So for example, maybe this Yosemite area, zooming all the way in, we can see all these highly detailed topographical contour lines appear. So if I were to zoom in right there, we can see that that line happens at 750 meters of elevation. So this kind of style is very useful when it comes to outdoors mapping or tracking scenarios. Now, in the odd case that the 6 built-in background map styles in Tableau aren't quite good enough for your use case, you can do even more customized things. For example, going back to that top of the screen, clicking Map, Background Maps, Manage Maps, and then Add, we have options to integrate a WMS server or a Mapbox map in Tableau. Now, a WMS server is a web map service, and essentially, these are typically used in secure environments. So if you have your own in-house customized background map that you want to bring into Tableau that just lives in your environment, you can do that with a simple copy and paste of a URL. Or you can use a service called Mapbox to bring in your own customized map. Let me actually show you one that I made. So here we have mapbox.com. This is my account, my studio, where I've built a bunch of different map styles. We can see some here. We've got a navigation preview style, basic, North Star. In this case, I'll check out North Star. We'll let that thing load in for a sec. Cool. So North Star, as you can see here, is fully customized. I've chosen every single element in this background map. I've chosen the color, the font, what layers are there, what layers are missing. I've uploaded my own custom bathymetry or ocean depth layer. I've also chosen things like line thickness. And zooming all the way in, I can see that road networks appear. So I've also customized at what zoom levels different layers appear in the map. And I want this map in Tableau. To do that, we'll go to the top right-hand corner of the screen where it says Share, and click on that. So now we have the Share dialog in Mapbox. We'll click Third Party. In the dropdown, we'll click on Tableau and copy that URL. Now going back into Tableau, I click on Add, Mapbox Maps, give it a name. In this case, I guess we can call it Mine, and paste in that URL that we just got from the web page. And click OK. So just like that, Tableau has loaded in my customized Mapbox map directly for use in this background. So here I can see that same bathymetric shading of the ocean depths, as well as my color scheme that I picked out. And again, just like before, all these different map layers can be turned on and off in that far left-hand side of the screen in the Map Layers pane. OK, so that was kind of cool, but we got kind of off track. But the whole point of this was looking at crimes in SF from the beginning. So what we have here, if you recall, is this map that shows locations of crimes in SF. And here we have the police districts in SF. But what I want is to have these two data sets joined together. I want this map here to be shaded by the crimes that occurred in each district. So we have a darker color where there's more crimes and a lighter color where there's fewer crimes. So let's join those data sets together. Now in this case, if you recall, we had one shapefile that you see here and an Excel file, which was the crimes data set. But in Tableau, it doesn't matter. We can just join those two together as if there were any other standard file types. To do that, we'll go to the bottom left-hand corner of the screen where it says Data Source, and click on that. So here we've got our shapefile that shows, again, those police districts, right? Now let's add in that crimes data set from before. In the top left corner of the screen, we'll click the blue Add button, Excel, and we'll load in that SF crimes worksheet, spreadsheet from before, and click OK. So now we have to actually join those two files together. In this case, we happen to note that the field in common was police district. So let's select that. So here we'll choose district on the left side, and we'll choose police district on the right side. And we'll stick with that inner join. So now in the bottom half of the screen in that data preview window, we've now joined together that shapefile and the spreadsheet as if there were any other file types. It's nothing special. Now going back to this police districts worksheet where we've got these police boundaries loaded in, we can simply take number of records from the bottom left-hand corner of the screen, which is the number of rows that are in that joined data set, and drag that onto the view. Now in this case, I wanted that color-coordinated map, so I'll take number of records and put it onto color in the marks card, just like this. So now we have a joined map that shows us which districts have more crime in SF. So for example, if I was ever going to move back to the city, I might not want to live in the central, northern, or mission districts. But be careful, right? We might have also just fallen into one trap that's common with maps. We may have accidentally just made a map of population in SF. Because if you've been to the city before, you know that in the top right-hand corner of the screen, that's where more people live in the city of San Francisco. So of course, it stands to reason that where there is more people, there's more crime. So if I wanted to go one step further in that direction, I might join in a data set that has population numbers for each district in SF, join that in, and do a crime per capita calculation. So we can show the crime rates in SF. But in this case, I won't do that. I'll go a different direction because I want to know what types of crimes occur in each district. So I want to see a bar chart that shows, if I were to select the Taraval district, what crimes occurred in that district. Let's figure out how to do that. So first we'll go to the crime types worksheet at the bottom of the screen, which is blank, and we'll make that bar chart that shows crimes in SF. So here we'll take incident category from the left-hand side of the screen and put that onto rows. Then we can again take number of records from the bottom left corner of the screen and put that onto columns. And Tableau knows that we want to see a bar chart. We can also sort this bar chart by clicking the sort icon right there at the top of the screen. And we can see that larceny theft is by far the most commonly occurring crime in SF, followed up by other miscellaneous, assault, non-criminal crimes, and malicious mischief. Okay, that's cool. But again, my goal here is to see which crimes occur in which district in a connected view. So let's build that. We'll go down to the crimes by district dashboard at the bottom of the screen, which again is currently blank. And we'll load in those two worksheets that we just made, the map and the bar chart. So here I can take the police district sheet, put it on the view. Then I can take the crime types worksheet, that bar chart, and put that in the bottom half as well. So now the goal here, my real goal, is when I select Northern, I want that bar chart to update in response to my selection via what's called a filter action in Tableau. To do that, it's very simple. We'll click on this small filter icon in the top right-hand corner of the screen. And that's it. So now I can select the Central District and see that bar chart update in the bottom half of the screen. Now here it looks like in the Central District, larceny theft is still by far the most common crime, followed by miscellaneous, mischief, non-criminal, and assault. But then looking at the Terravale District, for example, again, larceny theft is up there, but the other bar charts clearly updated in response to that selection. Okay, so to recap, so far we've explored connecting to Excel spreadsheets, connecting to a shapefile, and how to use Tableau background map styles. But what if all those 6 styles in custom Mapbox and WMS, what if that's not enough for me? What if I want something even more custom? For example, what if I work here in the Mandalay Bay, and I have a map that shows the casino floor, and I want to know which slot machines are more and less profitable? Or maybe I work in a Walmart, and I want to know which of my shelves are stocked and which ones are empty on a floor plan. Or in my case, I love to travel, and I wanted to know in Disneyland which rides are more and less fun. So let's answer that question right now. So in the bottom of the screen, we'll click on Disneyland, and we can see that I've already actually loaded in my Disneyland data set. Looking at the data, by going back to the data source page in the bottom left corner of the screen, we can see what's in this data set. We've got the attraction name, we've got the attraction area, a description of the ride, the cohort of the particular row. So what we're seeing here actually is each row for the ride is the rating that was given by a certain cohort, adults, grade school, senior citizens, teens, etc. The rating given by that cohort, and finally the XY coordinate of the ride. You can see based on these numbers here, these XY coordinates are small numbers, right? 6, 4, 7.74, and I can tell you that these XY coordinates vary from 0 to 10. And what I want to do is I want to visualize all of my Disneyland rides on a map of Disneyland. Let's do that. So here, going back to my Disneyland worksheet, I can customize that background map again by going to the top of the screen, clicking Map, Background Images, and choosing my data source file, which in this case was called Sheet 1 Disneyland Rides Final. Now clicking on that brings up the Background Images dialog. We can add an image, browse for the image, and in this case, I know that the image is called disneylandmap.jpg, and we'll hit open. So now what we got to do is tell Tableau what our metrics, what our axes are for this map. Because one way to think about a map is, in general, we have latitudes, longitudes, x's and y's. A map is nothing more than a giant graph. And what we really choose for those x and y coordinates really doesn't matter, the units, as long as we're consistent between the map and our data source itself. So if you recall, in my data source, my xy coordinates varied from 0 to 10. So in this case, I'll choose the x and the y to vary from 0 to 10 as well. So here, the left one I'll mark as 0, and the right I'll say is 10. For the y field, I'll choose the y field. The bottom will be 0, and the top will be 10. And this map here, we can see the preview. It looks pretty vibrant, so we'll actually go ahead and wash that out just a little bit so that it's easier for us to see our data when we do bring it in. Now, clicking on Options at the top of the menu, we can also check the Always Show Entire Image option. Then we'll click OK. Okay, well, that's cool. There's still no map. To tell Tableau to use our map of Disneyland, we'll go back to that map menu at the top of the screen, click Background Maps, and hit None. That tells Tableau to not use the Tableau built-in maps and to instead use our image that we just loaded in. Now all we've got to do is load in our data. So if you recall from our data source, the x and y coordinates are what we're going to use to plot each ride in Disneyland. So we'll take the x value and put that onto columns. We'll take the y value and put that onto rows. And now we have a map of Disneyland. There's one mark right there. It's really faint in the middle, so I'll make that a circle type, and I'll make it a little bit bigger as well so we can all see it. And it looks like we only have one ride in Disneyland. That can't be right. You guys know what's going on here? Exactly. Just like before, Tableau is averaging all of the ride's coordinates into one. So we need to, again, break it apart. So we'll take the unique identifier, in this case, which is attraction name, and put that onto detail. So now we have one mark drawn on the map for every ride in Disneyland in the right spot. Now, I do want to point out that those XY coordinates that I generated earlier actually came from me looking at this map and finding the exact coordinates on this view. The way I can do that is, so for example, let's just say that there was a ride here in Star Wars Galaxy's Edge. I can right-click, click Annotate, Point, and that tells me the exact XY coordinates on this map of that ride. So what I actually did was I went in and I found the XY coordinates of every single ride on this map and put that into my data set. That's how Tableau knows where to draw each ride. Let me delete that for now. So this is cool. We can hover over each one and see that Roger Rabbit's cartoon spins up there in Mickey Toontown, and Big Thunder Mountain is in Frontierland. I love that ride. But what we want to see really is, again, that rating of each ride. Let's have a look at that. We'll take the rating measure from the bottom left-hand corner of the screen and put that onto color. If you see in the top right-hand corner, a legend has appeared that shows us the sum of the ratings of each ride in this gold and purple color scheme. But we don't want the sum, right? We want the average, because you recall we actually have 5 rows for each ride. So we'll take that sum in the marks card, hit the drop-down, and change that to an average. But again, be careful, because in our data set, we have one cohort for each row. And what we're showing here is the average of averages. Right? We're saying overall, across all cohorts, these are the average ratings. But that's not necessarily an actually good metric, because each cohort might have been a different size. We might have had more kids and fewer adults, for example. So we actually want to break these ratings apart by different cohorts. To do that, we'll go to the top left corner of the screen where it says Cohort and drag that onto Filters. We'll select all values and click OK. Then in the Filter shelf right here, we'll click that drop-down and click Show Filter. Now in the top right corner of the screen, the Filter dialog has appeared. But again, we want to see one cohort at a time because we cannot combine different cohorts. So we'll customize that view by clicking the drop-down menu and clicking Single Value List. This makes it so that we can only select one cohort at a time. So now we can see we selected adults, and adults really like Star Wars Galaxy's Edge. I'll make that a bit bigger. They really like Galaxy's Edge, and they really don't like what's happening up here in Toontown. Whereas if I were in grade school, that changes. I really like Toontown, and I don't like Star Wars Galaxy's Edge. Maybe I'm afraid of the roller coaster. I don't know. Now, if we wanted to go a bit further in this analysis, we might end up with a dashboard that looks like this. So what I've done here is actually loaded in custom images at the top of the screen that shows the logo of each land in Disneyland. I can click on any land. So for example, if I want to go to Fantasyland, I can see the map and the bar chart update in response to that selection. So the bar chart on the left shows us all the rides that are in. This is the wrong land. I guess I matched them up incorrectly. But imagine that this was actually Fantasyland. It would show us all the rides in Fantasyland. and it would show us the selections of all the rides on the map in Fantasyland. Yeah, it looks like I've accidentally matched this one up to Frontierland. We get the idea. All right. So as a recap, we started off by loading in the superstore data set. We learned how to connect to location data in a spreadsheet. We learned how to use geocoding and how geographic roles work in Tableau. We learned about hierarchies and how to drill up and down. And finally about different map types, like shaded maps, point maps, label maps. We then looked at UFO sightings in the United States. We saw how to make a density or a heat map, how to toggle background map styles between light, normal, and dark, how to toggle map layers, and how to make a connected dashboard. Then we looked at crimes in SF and saw different background map styles like streets, outdoors, satellite, and even how to load in a WMS map or a custom map box style. And again, we saw how to connect different dashboard zones with a filter action. And finally, we looked at Disneyland, the happiest place on earth, and saw how to load in our own custom background image and how to use custom icons in Tableau. That's all I got for you today. Thank you all so much for coming. Yeah, thanks.